So let's take a look at 7.2. We are going to talk about inverse relations and functions. I want you to think about 1, 2, and 3 on your own really quick and try to graph those. These are all things that you've done before. The first one I do want to change though. So instead of y equals negative x plus 4, think about it as y equals negative 1/2 x plus 4. Okay, so try to use some prior knowledge and graph these, and then I will go over it with you. All right, so at this point, hopefully you were able to come up with something for these. The first one was in slope-intercept form, so you were good to go. We moved up 4 and then down 1/2. Hopefully that one felt pretty good to you. Remember, you plot your y-intercept and then move your slope. For number 2, it was in standard form, which means that you needed to get it into slope-inter form by solving for y. And when you did that, you got negative 3 plus 2x. So you would start at your y-intercept, which is negative 3, and then move your slope, which is 2/1. So up 2/1, up 2/1, and so on. Number 3, this actually was from chapter 5. So this is your parabola, right? And we talked about that a little bit last chapter, but we didn't do much graphing without your calculator. And maybe you use your calculator to help you out here. That would have been totally fine. So with parabolas, we would move up 4, and then we use our magic 1, 3, 5, right, to then move over 1, up 3, over 1, over 1, up 1, over 1, up 3, over 1, up 5. Okay, so what we're going to do today is we are going to do inverses, okay, and inverses will come directly off of reflecting a graph across this line here, y equals x. And we are going to do that with all of these later after we get a little further in our stuff. Okay, but essentially what we're going to do is just reflect it across these lines. Okay, so this is kind of like the mirror, right? And so it'll have a mirror image on the other side. Okay, does that make sense? Hopefully. So let's talk about relations in general. Okay, a relation is a set of ordered pairs. Okay, now with it being a set of ordered pairs, I hope we realize that graphs are that, right? These graphs, although they are not just a bunch of points, they technically are, right? Even though it's a line or a parabola, we have a bunch of points making that up, so they are sets of ordered pairs, okay? But relations, we're really going to focus on just like actual ordered pairs a lot of the time, but not all the time, okay? The big vocab from today is an inverse relation, and that's basically when you switch x and y. And we will talk about that on the graph above as well. Okay, so what I would like for you to do right now is to go to Desmos.com, okay, use the calculator from there, graph each problem above, and then along with its inverse. So what I want you to do is draw the inverse on your paper with a different colored pen or pencil, and then describe what you see or notice, okay, which probably will be that it reflects over it. But the main thing is I just want you to kind of do that part on your own. So go to Desmos.com and type in the inverse. And the inverse, basically what you're going to do is type in x equals 1/2 y plus 4. Okay, so you're going to graph the opposite of it. So this would be x equals negative 3 plus 2y. And this would be x equals y squared plus 4. And just see what that turns into. Okay, so go ahead and do that. All right, so the green functions are what you should have came up with. And number 2, I had a sign issue, so I had to fix that. Hopefully you caught that as you were going. It should have been minus 2x for the original, and I had plus 2. So I had that going in the wrong direction. So I changed the whole thing. But again, as you see, it's definitely reflecting over that axis, right, that I drew. And that's a little bit easier to see with number 3, I feel like. Hopefully with number 3, you can see that it is the same pattern of that 1, 3, 5, but it's just sideways. So it's down 1/1, down 1/3, down 1/5 instead of over 1 up 1 over 1 up 3 over 1 up 5, right? Also, something about the slopes of the lines. So basically what happens with them is they are the reciprocals. Now, they're not the opposite reciprocals. That would make them perpendicular, which these are obviously not perpendicular, right? But they are reciprocals, and that might be something that helps you in the future. Okay, so that's just looking at it graph-wise. Let's go ahead and talk about how to do this for real, okay? So remember that f of x is just another fancy way of saying y, okay? So technically this is y equals 4x minus 3, okay? So what we're going to do is find the inverse. And the way that you find the inverse is to switch x and y in the equation. So now we have x equals 4y minus 3. And then it says solve for y. Okay, solve for our new y, we should say. Okay, so if we want to solve for y, I would add 3. And we have x plus 3 equals 4y. And we would divide by 4. Okay, so if I want to rewrite this, y equals 1/4 x plus 3/4. Okay, now the only thing that I want to add is switch it to inverse. Oop. Be nice if I could spell it right. It to inverse. Okay, so the inverse notation is f, and then there's this little -1 of x, and it's 1/4 x plus 3/4. Okay, so that's the inverse of f of x equals 1/4 x plus 3/4. Okay, now it's even easier when it comes to ones that just have points. Okay, so we switch x and y, which is step number 1. So 2, -4, 3, 0, 6, 5, 9, 7. Now, because I don't have an x and y to solve for, this is your final answer. You just switch x and y. So if we look at the next page, it says find the inverse of the following relations, then graph the original and its inverse. So I'm actually going to graph the original first. Okay, so let's go ahead and graph these points. So -8, -3. Then we have -8, -6. -3, -6. And let's see what happens when we flip it. So remember the inverse, we just switch x and y. So now we have -3, -8, -6, -8, and -6, -3. So let's plot those. -3, -8, -6, -8, and -3, -6. Nope, -6, -3. Sorry, I said it wrong. Oh my God, and I plotted it wrong. Here we go. Okay, so again, it is kind of hard to really see. Remember, there is this imaginary line here, right? So you can see what's being reflected, right? These two are the same. Oops. These two are the same distance away. These two are the same distance away. So it really is the inverse just by doing it that way. It's just hard to picture when you're just plotting points. All right, so we're going to do the same process in number 7. Okay, this time we can't just plot the points, right? So we're going to have to graph this line first. So this is already in slope-intercept form. So we move down 6, and then our slope is 2. So up 2 over 1, up 2 over 1, and so on, right? So I'd like to go a couple different points in both directions just because it's easier to draw the line, and we want it all the way through the graph. And now we're going to go ahead and start the process of finding the inverse. So when we're finding the inverse, we switch x and y. And now we solve for our new y. So we would add 6. So x plus 6 equals 2y. Divide by 2. And that means y equals 1/2 x plus 3. Now remember, when we write our inverse, we want to say the inverse of f of x by doing that little -1 as the exponent. So we move down 3, which is our y-intercept, and our slope is now 1/2. So up 1 over 2, up 1 over 2, up 1 over 2, and then I like to go the other way, down 1 over 2, down 1 over 2, and so on. And there we are. So again, we're going to do this with our other graph. Okay, this one, make sure that you're careful when you're solving. Okay, but again, we have f of x equals x squared plus 1. So that plus 1 means that we're moving up 1. And then we move our 1, 3, 5. Remember, technically we are multiplying this by our a value, but if our a value is 1, it just stays 1, 3, 5, right? So over 1 up 1, over 1 up 3, over 1 up 5. Same thing on the other side. And there is our parabola. Then we move on to find our inverse. So we have y equals x squared plus 1. Again, we are going to flip x and y. So x equals y squared plus 1 and solve. If we subtract 1, we get x minus 1 equals y squared. And then we're going to take the square root. Remember, when we take the square root, we always need to write plus or minus. So this needs to change to f inverse of x equals plus or minus the square root of x minus 1. Okay, now this is harder to see. You might need to use the table in your graph. You can do just about anything that you feel like you need to do with these. The big thing is, honestly, like here is our line, right, that we need to reflect over. So we can see pretty much where it needs to go. Okay, essentially what's always going to happen is whatever this y-intercept is going to become your x-intercept. Okay, and then we move our 1, 3, 5 just in the opposite way. So up 1 over 1, up 1 over 3, up 1 over 5. And the same thing on the opposite side. Okay, so you have options. Again, you can use your table, and you could plug this into your calculator and use your table of values. And the reason why you need the plus or minus is because this graph is actually split in half by the x-axis, and the top part would be the positive part of that, and then the bottom part would be the negative part of it. So that's why you need that plus or minus in your final answer. Okay, so that's it for day 1. We do have day 2 directly under this. So your homework is going to be underneath that. So make sure you are mindful of what you are grabbing next so that you're not grabbing the wrong thing for your homework.